And it's my great pleasure to introduce you to Carrie Longley. She's a studio artist and educator. We have very, very rarely studio artists here which present. However, in many cases, whenever scientists and artists collaborate, it's something truly unique because both have to go way out of their comfort zones, but at the same time, they are also sometimes creating things that are truly magical. Carrie is currently an assistant professor of fine art and the chair of the Fine Art and Performing Arts Department at Indiana University East. She holds a BA in studio art from Wittenberg University and an MFA from Indiana University in Bloomington. And here in Bloomington is also when we two first met. She exhibits her work extensively throughout the United States and has received numerous awards, including Emerging Craftsman from Ohio Designer Craftsman and the Bobby Candice Award at the Penland School of Crafts, and the MCACD Individual Artist Fellowship and the William Dorothy Yeck Young Sculptors Award. So it's my great pleasure to have her here and speak on recontextualizing form and surface. Thank you very much.
Thank you, Dr. Borner. Can you all hear me okay? The first part of this lecture is going to be a little bit of background on the project. The second part is going to be a brainstorming where I'm actually going to ask you for your participation. So it's vital that you see the images up on the screen clearly. If you could you move as close as possible to the front and the central part of the room? And I'll give you a few moments to get resituated. And if you haven't done so already, make sure you have one of these handouts. It's a word bank for the brainstorming part, the last half of the lecture. So while you get situated, I'll explain a little bit about my initial purpose for making. This project kind of fell into my laps, so to speak, a few years ago. Dr. Borner saw my work in 2009 during my MFA thesis show and talked to me during the opening about using my skill set to visualize data. And at that time, it was very abstract to me. I was just coming off of rallying for a cohesive exhibition based on the theme of wonder and curiosity. And this theme is still driving my work in this visualization project, but I love this definition of wonder. Wonder defined as a form of learning, an intermediate, highly particular state akin to a sort of suspension of the mind between ignorance and enlightenment that marks the end of unknowing and the beginning of knowing. So as a maker and as an artist, I celebrate the ignorant side of wonder, the imaginative side. I love myths, fantasy, surrealism. This data visualization project has been very challenging for me as a maker because I'm now in the whole spectrum of wonder and curiosity, having to move towards the enlightenment side, okay, the knowing side. So if I were to give you a visual representation of the spectrum of wonder, of curiosity, on the left we have an artifact from the Museum of Jurassic Technology. This is a real museum outside of LA that displays fake artifacts as real in an authentic setting. Okay, so the theme of this exhibition, the mice on toast, the idea behind it is that if you give a child who has a bedwetting problem mice on toast, it will cure their bedwetting. Okay, this is legend, this is fake, but as an artist, this is the stuff I love. It's ignorant, it's fun, it's fantasy, it's surreal. On the right side is a zombified Amazonian ant. It's been infected by a parasitic fungus. The fungus kind of has control over the ant, encourages it to climb to the tallest part of the rainforest where the fungus explodes out of its skull. The spores flutter to the bottom of the rainforest floor. It infects more ants, and those ants get into this zombie state and complete the cycle of this parasitic spore. That is real. So that's kind of the spectrum of wonder, spectrum of curiosity that I really enjoy. This is the show that Dr. Borner saw in 2009. I display my work as though it's an authentic scientific specimen. So again, I like viewers to question whether the pieces are models of specimens from our world or something from the artist's imagination. My previous visual language before starting this visualization project with Dr. Borner was limited by the rules of anatomy, by muscle groups, by a central axis, by bilateral symmetry, the central axis being the spine. So this project has been especially challenging for me because I already had a visual formula. So the formula was anatomy. And within that formula, I would explore. I would be more creative. When I started to think about how I was going to organize a data visualization sculpture, Dr. Borner approached me. She talked about how she reached out to me because my language was organic and data grows organically. It doesn't grow in a linear fashion. It grows from all directions. So I immediately started to think about another visual formula that I could use other than the rules of anatomy. And Ernst Haeckel, 19th century German philosopher, artist, naturalist, he's an artist that I looked to for inspiration before the science mapping project began. So I immediately went back to his rules of organization, and the tree was a common theme that comes up with organizing science. Another reason why I love Haeckel's work is he takes a lot of artistic license. So at this time, these artists were charged with educating the public on their natural world. Photography wasn't prevalent at that time. So these artists would take a lot of artistic license. They would romanticize the natural world. And that's one fun aspect of this project, is that yes, I have to, my visual language has to be attached to data, to science, but I also can take some artistic license like Haeckel did. This is the underside of a octopus. Obviously, we know today that the underside of an octopus does not look like this. I found myself poring over the imagery from the science mapping, from the previous science mapping exhibits. Some of my favorites were this by Daniel Ziegler, if I'm pronouncing his name correctly. Very organic language, so it's obvious why I was drawn to this form. But what I love about his pieces or his illustrations was that they had dimension. They weren't as flat as a lot of the maps that I was looking at. They had cross sections. Dr. Borner drew associations with the use of wire in my work to the use of lines in Daniel's work to draw connections between distant fields of science. And so this is the first surface prototype that I came up with for mapping relationships of science. Initially, this project was so abstract, it was really difficult for me to grasp. So I was still so ingrained in this bilateral symmetry, rules of anatomy, that I was like, okay, I'll just think about surface, what this surface could look like. So I started to think about these wires. If I were to do dimensional wires, such as Daniel's pieces, what would the thickness of the wires mean? How many wires should be represented? How would this be attached to specific information? So the wires here represent collaborations between distant fields of science. Canals represent legends or erosion of knowledge. Right now we have lots and lots of information out there. Not all of it is accurate. So how do we represent knowledge voids or erosion of knowledge? Another surface detail. So here I start to think about, like, if we were to take a cross section of data, what might that look like in 3 dimensions? We saw what it looked like in Daniel's illustration. But in 3 dimensions, would a deeper layer be more knowledge growth during that time? Would they overlap? Would they connect in certain areas? This is another one of my favorite maps from the exhibit. History of science fiction reminds me of a digestive system, so I love the tunnels, the canals, the organic quality represented in this illustration. Many times, if things are really hard for me to grasp, I copy them. So I was like, okay, I'll try making a 3D model of the history of science fiction and see what I can learn from the process of sculpting that drawing and see what kind of new elements I can put in. So here it has 3 roots representing 3 stages of science. I started to incorporate the wire. But again, it's still anatomical, still has a sense of bilateral symmetry of an organism, not as organized as I would hope. Another inspiration, my husband's here today. He's an artist, a 2D artist. I have a really difficult time recording ideas in my sketchbook, trying to transform 3 dimensions into 2 dimensions. So he and I collaborated a lot in the initial stages of this project. This is some of Kevin's work, self-portrait and a portrait of John. So he's very good at recording 3-dimensional language on paper. So these are some of the initial ones. We sit in my studio. I would describe to him what I'm thinking about: spiraling growth, similar to like a nautilus shell, incorporating warts and hair to represent growth, voids in the center. Again, thinking about an underlying skeletal framework, a framework of data and then information growing like skin on top of that. The initial roots of knowledge in the distance. And here's where I felt like I started to make a shift of thinking about a different organizing principle other than a central axis or a spine. And I was heavily inspired. I have 4 children at home, constantly have a lot of visual information with regard to toys and children's books that inspire me. And I was thinking of the child stacking toy with this one. So a central axis, almost like a totem-like sculpture. So this central axis, I was thinking, could represent a timeline at this point. I was also thinking about organic growth, like Dr. Borner had suggested in our initial meeting. That is what characterizes data growth. It's organic. It's growing in all directions. And I live out in the country. I'm constantly inspired by organic growth on my property. And I was thinking about the hickory jack mushroom. So it's growing off of a central axis. It's growing horizontally. There's a cross-section involved. Mushrooms also inspired my previous work. The morel mushroom was very inspirational in creating these little heads on the organisms that I would sculpt. So kind of no surprise that I came full circle back to the hickory jack mushroom. And it kind of limited the visual language in a way too, because all I had to think about was a central axis and then horizontal growth, and then growth up and down from that horizontal platform. So initially I was kind of looking at the big picture, tried to look at surface, and then tried to kind of narrow it down into parameters for myself so I didn't get overwhelmed. So that's what that hickory jack mushroom form does for me, is it gives me limitations to then explore within those barriers. So this was the sketch that came off of that thought. So it would be organized historically by time, starting with 17th century to the present. And my thought was that in theory, older scientific fields would have more data, in theory. So they would be located near the bottom of the platform. Newer fields of science near the top, informatics, computer sciences. In theory, less data, smaller platform. I had this sketch set on it for a while, for months, and just could not motivate myself to sculpt it. I was terrified by the thought of assuming that because a field is older, it would have more data. And so it was really hard for me to quantify how big those platforms should be. So then I moved on, or I found this flow chart online, which was kind of inspirational, where it orders the branches of science, the scientific fields, by the scale of the universe, so the subject in which they study. This was an epiphany for me, because now I could quantify the size of those platforms, okay? And then I moved to this sketch here. So similar visually, but ordered a little bit differently. So you have cosmology would be the largest platform near the bottom, and the logical, or math, logic, formal sciences would be near the top. So this is how the sketching started. There it's ordered by the scale of the universe. I start to add in the platforms. And then we have kind of subdisciplines, sociology, psychology. They're all on the same scale. All study sociology, human groups, psychology, individual humans, okay? So if these are, and this is a question, a reminder, this project is very much in progress. So as I'm talking, I want you to start thinking about how you would render these disciplines visually, which is why I gave you a word bank. On the back are the fields that I need to render. So I'm going to ask for your feedback. For fields that study the same particle size, the same subject size, they're on the same platform, how do you represent those? Do they branch up? Do they branch down? Do they split, like dividing cells? Is the order important? Does it need to be organized from smallest to largest, or could it be mixed up? So for instance, astrophysics, that's a connecting field. So, astronomy in theory would be near the bottom, physics would be near the top. Should I take this sculpture apart and reorder it? Should it be shaped like a cone? And here I start to add in the scientific fields. In a conversation, Dr. Borner shared with me this color coding system that relate to the different fields. So already this starts to get me thinking of the color of this sculpture. It doesn't need to be anemic like my sculptural work. It doesn't need to be bloodless, colorless. These different platforms can have these color associations that are already assigned to them based on the discipline that they represent. So I start to create a half-scale model in my studio. So these are thrown forms that are kind of like these solid bowl forms that will sink into one another based on the children's stacking toy. And again, there's a central rod that's threaded up through these. So these can be reorganized, not necessarily ranging from smallest to largest at the bottom. So this is just the central axis. And then I also have these thick thrown slabs. These are in the cheese hard state of clay. So in clay, at this stage, we can add, we can carve, we can stamp. So I've kept this sculpture in this stage, and it's very, very malleable stage until I talk to you guys, until I brainstorm with you guys. So I'm really hoping that you're brainstorming as I'm talking about some good ideas. The only one that I was like, I know exactly what this needs to be is a psychology platform. It's a study of the mind. Obviously, it needs to be a brain. And one of the best parts of collaborating with Dr. Borner is that she's not an artist. She's a scientist. So when we talk about the final stage of this sculpture, she has these incredible ideas void of the limitations of being a maker. So she suggested, okay, maybe it has these geode forms that drop from it. The viewers come up, grab the geode, they can vote on their favorite platform, their favorite discipline, the favorite part of the sculpture. The last suggestion, the one that we're going to roll with, is a marble maze. So the sculpture at the top on the math and logic platform, the viewer can go up, place a marble on the math and logic platform, and it will trace down to each platform and become a marble run until it reaches the largest platform, which in theory would be cosmology. So when this brain form, the psychology platform, is finished, it will have tunnels that a marble can run down. So, but this is the only one where it was like, I know this has to be a brain, and it's still in progress, very much in progress. I just have the pattern of the brain carved in there. The rest of them, as you can see, are just cheese hard, thick slabs. Again, that can have tunnels added up, tunnels added down, holes, voids. And just to reinforce, here's an information map that shows how all of the different disciplines intersect, all of these hairs that are connecting the different scientific disciplines. So they don't stand alone. So a single platform will not be okay. They have to be connected in some way, through tunnels, through wires. So this is the brainstorming part. This is where I need your help. I've given you a word bank. Of course, you can come up with your own words. This is just to use as a starting point. For the field of astronomy, scientific study of stars, planets, and other objects in outer space. So fields, just a few fields that are included in astronomy: planetary science, cosmology. Its color code would be mahogany, okay? Pretty rich color. So we know the color that this part of the piece is going to be. And the idea, I guess I didn't outline this, and if I'll draw on this screen. Going back to that hickory jack mushroom, the idea is that these platforms will be added on the sides, so branching out, okay? Similar to how the hickory jack mushroom grows on the side of a tree. So these could have branches down. They could have tunnels up. There could be a track that runs along the trunk of the tree or the trunk of the sculpture. So all kinds of possibilities. Ooh, there we go. So how could we visualize astronomy, cosmology, planetary science? Stars is an obvious one. So if we're talking about surface, we could add stars on the surface. Yeah. So I would put that in the form. So spherical, you're thinking of spherical, you're thinking of reaching arms. Almost like a planetary model or something. So like nesting, kind of like cones in a way? Yeah. Okay, I'll let you try. Okay. So if I were to draw that, maybe something like where it's extending up and out, like this.
Yeah, so go down to like a really small cone.
Okay, so small to big. Okay. So at this point, I'm not thinking about how I'm going to get this marble to run through this sculpture. I'm going to think about that afterwards. I'm just thinking about the visual language of it. These are good. Yeah.
Some of the maps of the internet that use hyperbolic space, which really looks like galaxies. So it's like the idea before, where you kind of it's like an Escher type sort of drawing where you zoom in and then more as you zoom in, more detail of the network shifts around you. And I've seen physical models that to me look like a network of hyperbolic space, but I don't know how to explain it in words.
Okay.
Maybe I have to show you.
Now, a lot of these I'm going to do a Google image search on when I give hyperbolic space. That at least gives me a starting point,
Yeah.
and then I can do some more research after that.
So basically, it looks like clusters receding into the distance, and then you've got a cluster right up in view. And then as you zoom in, then the other cluster, or if you click on another cluster over here, it'll zoom into space, and then the other things are shift off into the background. And it's a way of representing a really large-scale data set in a tractable way, and it's using a different. This is where my mathematics leads me, but it's using a different type of space. It's not a Cartesian plane; it's a hyperbolic space. So,
Okay.
but I'd be happy to send you some, at least
Oh, yeah.
a digital, a 3D representation that I've seen.
Oh, I would love that. Thank you. But you're talking about like an extreme scale shift from like miniature to. Okay. 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 Great. Getting some good visuals here. So from a bird's eye view, from an aerial view, would this platform remain? You saw that my platforms were circular. Would this platform remain circular? Okay. So in that sense, there would be projections off of that circular platform. Okay. That's good. So next is Earth science. So these fields are sciences dealing with the Earth's atmosphere, hydrosphere, lithosphere, biosphere. So we have oceanography, climate, geology, meteorology. So if we're talking in just about form, think about it at the aerial view, the bird's eye view, and the profile view. Yeah, right. I think about, yeah, I think about, yeah. So spiraling, wave-like, organic. Mm-hmm. Right, right. Uh-oh. Cami? We lost our image here. I'm glad that you said that because as a clay artist, I'm thinking of Earth as core samples. You know, I work with Earth. So, of course, on this part, I was like, oh yeah, it has to have some kind of suggestion of the layers of the Earth down, not necessarily, you know, as well as Earth up.
So maybe that gives you surrounding areas, core samples.
Mm-hmm.
Then actually get to see different levels, such as ocean, sea, lithosphere, biosphere, etc. So you need core samples, but from the kind of atmospheric level down to the core,
Mm-hmm.
and you would have all the experience.
Right. Yeah.
I'm thinking spherical. Can't really describe an image, but where it's kind of bisected, you have different layers of the earth. You've got a core, you've got
Right. Yeah, right. Of course. You can draw it for me when we get home. Good spelling, good spelling. Okay. Anything else to add to this one? These are all good. So now we move to social science. So we're near the top of the platform, of the tree. The bottom platforms, a lot of the fields rest near the top. So these bottoms might be visually larger, but the fields will be more concentrated and closer together in the top, near the top. So sociology is what we would be illustrating with this one. Study of social behavior or society, including its origins, development, organization, networks, and institutions. I talked to an anthropologist a few weeks ago about this platform. He suggested looking at Rosetta Stone, looking at cave paintings. You know, if you're looking at the history, the origins of society, of social behavior, we could include, in addition to sculptural elements, we could include imagery and symbols. Mm-hmm. 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 Yeah, and think of the associations with that. Regardless of the form, I automatically think of the terracotta soldiers. So inevitably, the viewer is going to have associations. And that's an important association. So within this field of sociology, law, ethics, economics, how would you visualize ethics? That's our cultures, you know. Another good consideration or important consideration with this is the audience, right? So if the audience was here, then yeah, that would be an excellent representation of ethics. If the audience is overseas, I'll move on to the next. So here I have psychology. This is the one that I was sure about. But within that field, developmental cognitive. Is it enough to just have the brain sculpted with a marble track? Mm-hmm. Oh, nice. No. This is why I enjoy our collaboration, because you don't have limitations of a maker. Yeah. Yeah. Yeah, sure. No problem. Cami, we lost the image again. I don't know if I need to stop shaking.
Also, we now have, thanks to the network we have access to all kinds of great research. We can get even anatomical cuts,
Mm-hmm.
basically well, there are a number of researchers now which look at train tracks, and they try to identify which areas in the brain are there. So both of those provide more anatomically correct versions of the brain.
Right.
I also like your comments on kind of the artistic ability to abstract away
Right. 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 Mm-hmm. It's a solid mass, right? Mm-hmm. That's where maybe use of wire might be helpful. So introducing another material that's, has transparency. I could create a network of wires. And that would also show like neural pathways and connections. And yeah, that is a limitation of clay for sure. It's a solid mass. So a transparent element would be helpful. Right. Mm-hmm. So we had like, can you summarize your feedback there? Neural pathways illustrating like interconnections in the brain? Here, I can trade you too if this works. So I'm going to move on. Life science. So this might be most familiar to us. Functional biology, comparative physiology of plants and animals, comparing the way different kinds of organisms function in the context of their structure or anatomy, which I love to illustrate. So some fields in this. Physiology, medicine, ecology. We have a lot of different color codes in this area, so this might be a more colorful part of the sculpture.
Because this kind of projects forward what everything now is CRISPR and all these other very powerful techniques. And ultimately also hints at the fact that many of these sciences, they are working on ways of improving human health, also human anatomy, as we know it today.
Right.
And it would also show that this is something that we did by adding what you already knew
Mm-hmm.
to something new.
Right. Well, and think about the symmetry, just the visual symmetry of the plant and animal world. This is where I could start to introduce some of that symmetry back into it.
now that we have the global brain, all these brains connected in science, which build on each other, collaborate with each other, etc. And we also know that the social aspect of the environment in which we are living has a huge impact on how our brain grows, and if we are happy or depressed, potentially suicidal. And so if I just join one brain, I think it's appropriate here, but ultimately it's really not one brain.
Right.
It's multiple brains. And similarly for what we just discussed, the one organism, I think it's also multiple organisms, which in many cases you need to do reproduction. So it's not just one. And cells, again, it's multiple.
Right.
So I don't know how to decide if I should just show one or many of them. It's really a tough one.
And ecology, too. Visualizing ecology.
I mean, for Earth, for instance, you could show the moon. You could say, well, it's a body problem. For people, you could show a family. That's microcosm. Ecology, you could show a cycle of life or some kind of interesting feedback cycle. Like what you mentioned with the ants. That the parasite, I think, go up to the parasite. The crazy cat lady, it's the same. Yeah, maybe for now it's good to just be simple, and it will be hard to communicate so much data, which we're now all trying to practice one
Right.
structure to communicate that to people. Maybe I should step back and say, yeah, just one example of it. But it is interesting, philosophically, how many functions.
Right. And what disciplines to include, too. And I think it'll be important for me to reach out to specialists in these fields. You know, how would you summarize, how would you visualize your discipline? Like that anthropologist that was giving me, couldn't give me ideas fast enough about his field. You know, it would be certainly important to reach out to those specialists. They know their field best. So cellular biology, cell structure, function, revolves around the concept that the cell is the fundamental unit of life. Focusing on the cell permits a detailed understanding of the tissues and organisms that cells compose. So in this discipline, subfields, evolutionary biology, genetics. So if we're thinking about an aerial view or a profile view of the form, does it stay as a platform? Does it morph into a more dimensional form?
It's also the beginning of life, which is nice. Then at some point we could also show subdivision just by itself.
I think about just the line drawings of cells that I studied in middle school science were beautiful line drawings. And if those were turned into form, what would that look like? We start to move into symbols, too, being very important with these following fields. Genetics, I can think of a lot of symbols that are associated with the field of genetics. Right. The DNA. So in addition to sculpting the form, I have the ability to put imagery on the form. So with decal work, with drawing, hand drawing. So something to consider. So now we're into physical science, branch of science. Chemistry is a branch of science. Physical science that studies the composition, structure, properties, and change of matter. So materials, chemical reactions, color code would be blue for this area. Mm-hmm. Mm-hmm. So the field's already giving us some visual language to work with here. What's your major? Okay. Okay, great. Physics. So here we have natural science that involves the study of matter and its motion through space and time, along with related concepts such as energy and force. This is a part of the sculpture I wish could be kinetic, could be movable, could have a motor in it. But some of the fields in this, particle physics, thermodynamics. Oh, kind of like a maroon, deep red. Yeah, I was surprised at how specific these color codes were. Mm-hmm. So kind of a simulation of movement with the form. Yeah.
I mean, you could have the marble bring the movement in somehow.
Mm-hmm. Yeah, just by default, we have movement when the marble starts to roll around the piece. So maybe considering how this marble rolls on this platform will be very important. And again, this is where, thermodynamics, how would I visualize that? This is where talking to a specialist would be really important. So we move into formal science. Study of topics such as quantity, structure, space, change. Fields would be computer science, statistics, informatics. If we're thinking of bird's eye view, profile view of just the form, does this one stay as a platform or does it morph into something else? Okay. So very regular, symmetrical form. Okay. Mm-hmm. So this is where combining a printed form might be appropriate with that corresponds to the formula like Dr. Borner suggested. Informatics, how would you visualize informatics? Coding? Is it? Okay. And then the last one, logic, systematic study of the principles of valid inference and correct reasoning, philosophy, semantics, ethics, metaphysics. This one's harder to grasp. Mm-hmm. This is where transparency might be helpful. Maybe the top isn't constructed of clay, maybe it's constructed of a wire armature. For ethics? Mm-hmm. Good balance. Technically, that might be helpful too, since that's where the marble's going to start. Any other additions for this one? Mm-hmm. Yeah, yeah. Mm-hmm. So these are things that I'm considering as additional inclusions. Thank you so much for the brainstorming. That's a good starting point for me. We have all these emerging fields. How do I choose which fields to include? This is where artistic license comes in. Emerging fields, one that I'm most excited about is this number one, neuroparasitology, so brain bugs. I can think of 1,000,001 ways to illustrate that, to visualize that. These emerging fields, would they look like those growths that are starting, like in my surface prototypes, like kind of like sprouting berries? They're important to include, but you know, how do I include that there's limited data really in these emerging fields? Knowledge voids. How do I include those? Organization, as I mentioned before, does it need to be organized by the smallest to largest? Or could it be mixed up, depending on how fields connect and collaborations between fields? And then something that I'm consider all the time as a maker and as a ceramic artist is the strength of material. So after clay is fired, turns into ceramics, it's a permanent material, but it's also very fragile. I'm asking for viewers to interact with this piece. Do I consider a different type of material? Do I continue to use ceramic? Is a marble the best object to trace this path? Or should it be kind of a heavy rubber ball that might not cause as much damage? I saw a lot of you writing during my presentation today. If you would, think of some considerations or share those considerations with me. I'm happy to provide you with my email address. I really appreciate your thoughts and feedback. Are there any questions for me? Thank you.
This statement about do fields need to be arranged in order by scale, or how the fields are connected to one another, that's in regards to all of the fields that you mentioned about, not just these emerging fields.
Right, right.
Yeah, because that was during your presentation, that's what I was wondering, whether that would be a nice dimension to have somehow show how the fields connect to one another, branching out in some ways, but rather than this linear sort of structure that you've got.
Right.
I'm sure we make the design more complicated. Yeah, so I was thinking that would be great. And then also, I can't remember, how did you, earlier on you mentioned about, you had expectations about older fields having a larger body of research. How did you examine that? Was it based on data on the number of publications?
Well, no, that was just, I wasn't sure where to even begin with that.
Yeah, because I was thinking that, and then you moved into where you're showing scale based on the size of the universe compared to atoms,
right.
Scale. But I was thinking another way of bringing scale in could be on the basis
Right. That would be fascinating.
the databases and that might be interesting.
Mm-hmm.
And then just a couple more comments.
Sure.
I'm thinking about, but then we'd already moved to different pages. In terms of the slide, the field which says it's to do with computation and informatics, in terms of the surface, maybe you could do something with sort of transistors, like motherboards. I don't know.
Okay.
How to term, but,
Yeah.
sort of layers of transistors, because that's kind of what's underlying all of that work is computations.
Right.
And then the other thing about, I think we were stuck on how to visualize society or the social science. And one thing I was thinking of was maybe layers of society, like some sort of archaeological kind of, with different periods of development, architecture, from sort of prehistoric times up to
Oh, yeah.
society. But that might have a particular, it might end up appealing to a particular audience.
Right.
It may not be as general in terms of audiences, but that would want to know about visualizing that.
So that's great feedback. When you talk about transistors, you're talking about like interactive parts of this sculpture, or?
No, more just same way that you've been talking about maybe overlaying images onto the structures. Like,
Okay.
One idea is that, zeros and ones,
Mm-hmm.
but also I was thinking, I don't know how you would do it, whether it would actually be part of the carving, a part of the sculpture, or whether it would be a sort of a drawing that's overlaid, but like a circuit board.
Okay. Oh, okay.
Somehow,
Okay. Yeah, definitely. In one of our brainstorming sessions, Dr. Borner and I were talking about, if you've ever gone to a museum, sometimes there's models that have like little hot nodes on them where you could touch the node and it will bring up an information display. I've thought about how exciting that would be for these pieces if there was some kind of, little points that you could touch on that, because it is a large amount of data to include in one piece. If I could like open that up in certain areas to be a little bit even more interactive, not just the marble run. Thank you.